This brings us to the very important idea of rationalising the denominator. And I guess the question is, why is it so important to rationalise the denominator? Or maybe more to the point, when is it important to rationalise the denominator? What is the point of rationalising the denominator? Now let me give you an example. If we were dealing with trig, and I said, what's the sine of 45 degrees? Sine of 45 degrees, who remembers that one? Exact value. Thank you. 1 over root 2, but we didn't rationalise the denominator. We didn't feel the need to. So why was it okay to leave that one as 1 on root 2? Well, what's the big deal about rationalising the denominator? What could it possibly be? It makes it easier for comparison. Makes it a lot easier for comparison. Because you're dealing with fractions. If you can have a rational number on the bottom of the fraction, that 1 on root 2 we talked about, we could rewrite as root 2 on 2, but we could see that then as a half of root 2. We get a feel about size. So if we're comparing things, that's when it's really useful. Otherwise, I'll admit, I tend to not rationalise denominators unless I'm doing things like adding surds together. That could be handy, things like that. So 4 on root 2 then. The idea is I want to get rid of the problem. The problem is the square root. How do I get rid of it? Well, let's turn it into a rational number. So I'll multiply by the square root of 2. But of course I can't change the question. So I'll multiply the top by root 2 on 2. Essentially we're multiplying by 1. So we know the value doesn't change. We get 4 root 2 on 2. Oh, in this case 2 goes into 4 and it's just 2 root 2. 3 on 2 root 5. Sure, you could multiply top and bottom by 2 root 5. It's going to work, but it's a lot easier or a lot quicker if we just multiply by the surd. So root 5 on root 5, and we get 3 root 5 on 10. Now, if I'd gone 2 root 5 times 2 root 5, I just end up with something that then I would then have to cancel to simplify the fraction, but saves time. Here's where conjugate surds now become important, because we know that if we want to turn this into a rational number, we'll multiply by its conjugate. So we get that difference of 2 squares on the bottom of the fraction, which in this case just turns out to be 1, and we get 3 root 2 plus 3. You see this sort of question a lot, where you get 2 plus root 3 on 2 minus root 3, so the conjugates. Because of course to rationalise the denominator I multiply by the conjugates, so on the top I end up with a perfect square, and on the bottom I end up with the difference of 2 squares. It's just a nice little question. So we end up with 7 plus 4 root 3 for that one. Alrighty, that shall do us for today.